know you already know this, but let's go through it, because if you don't have a good foundation in exponents, logarithms are going to be a disaster. So we're going to try to get these exponents down really, really well. Okay, who can tell me what we do when we multiply numbers with the same base? What do we do with their exponents? What would this equal? X to the what? M plus n. Very, very good. We add the exponents. What do we do when we divide the numbers? Subtract the exponents. Very, very good. What do we do when we raise a power to another power? When we have one x but two exponents? Multiplying. Perfect. What's x to the 0th? 1. Always and forever. And what's x to the negative n? 1 over x to the n. Perfect. Let's try a few problems. 3x to the negative second. What's that going to equal?
3 over x squared.
Oh, I love you. 3 over x squared. That's exactly right. This is not 1 over 3x squared. Can somebody explain why that's wrong? What's wrong with that?
The 3 was to a negative power?
Exactly, exactly. Now, it would be a whole different ball game if we had this, right? But even that wouldn't be this, would it? What would this be? 1 over 9x squared. This would be 1 over quantity 3x squared, which would be 1 over 9x squared. Is that okay with everybody? Great. This is a huge mistake that's made. You guys got it right off the bat. You're awesome. Okay. What about this one? It's exactly the same thing. I think I meant to do something different, but I didn't. So it is exactly the same thing. Those parentheses don't mean a thing because there's nothing outside of them. All right, what about the next one?
125 over 8.
What would that be? 125 over 8. That's exactly right. 125 over 8. What about this? Negative 4 nines. Perfect. You guys are doing great. Anybody have any questions so far? All right, now we got one that's a little bit more challenging here. It's probably going to take us more than one step to get this cleaned up. What would you suggest we do first? I heard somebody say something, but I didn't understand it.
Solve for the bottom and top. Solve for like the numerator and solve for the denominator.
Okay, I'm not sure what you mean when you say solve. I'm just not
Okay,
understanding
so,
what you mean.
distribute the exponent to the
Oh,
the
so-
numerator and
so-
do the same thing to the
So
denominator.
take that 2 all the way through the whole thing. Okay, now, want to clarify, make sure everybody's good. That's okay, but that isn't the way you have to start. There are other things you could do to get started, but doing that is fine. So since he suggested it, we'll go ahead and do it. Now that does include the coefficients. So 2 squared is going to give us 4. Now, you got x to the negative 4th to the 2nd. So you told me just a minute ago, I erased it, but that's going to be a multiply, right? So x to the negative 8. Y to the 6th. Remember, we're multiplying. 3 squared, x squared, and y to the negative 14. Again, you didn't have to do that first, but it's fine. I'll do it first. All right, so having done that, now what would you like to do? Negative exponents are just not a good thing. So we'll make those exponents positive by moving the variable. So this will be, our 4 is going to stay there and our 9 is going to stay there. But this guy is going to come to the bottom but this guy is gonna go to the top. Remember, if it has a negative exponent, it switches position in the fraction. Now, what about these guys? Can that be simplified? Yep. 4y to the 20th over 9x to the 10th. Perfect. Anybody have a question about that? Now, if you did that problem in a different order, it's fine, but you should get that same answer. Okay, what about this guy? Magnificent things about math is there's always more than one way to do the problem. What would you like to do first?
Simplify the left, parentheses.
This guy?
Yeah.
Right here? Now, since that negative is on the whole fraction, instead of distributing the -3, does it make sense that I could just flip the whole fraction? So I would have 2y over 7x cubed. And now I can do my cubing, so I'll have 8y cubed. I don't even know what 7 cubed is. Is that
343.
343 x cubed? All right, so he wanted to deal with the first fraction first. Everybody okay with that? Now, this one doesn't have an exponent out here, so we can just start moving things around. So I'll leave the 14 and the 8. Now, what's this guy gonna do? He's gonna come down, right? So 3 of them are coming down, but there's already one down there. So is that x to the 4th on the bottom? Because these 3 are coming down to join this one.
Yep.
Now, here we got a little messiness going on. We got 4 coming down and 6 going up. Is that all right? So that's gonna leave me basically with 2 up here. All right, here we go. What simplifies? Let's see. Can I cross these 8s out?
Yep.
343 was 7 cubed.
Yeah.
So I'm gonna take a 7 out of that and a 7 out of this. Does that make sense to everybody? So it looks like on the top I got a 2 and a y to the 5th. And on the bottom, I've got a 49 x to the 7th. Whoa, what a mess that was. Everybody okay? All right, try the next one on your own. Try G. Brady, you got it done?
I think so.
Okay, good. Are you shy about being on video, or would you come up and put your work on the board for us? You can bring your friend. You can go together.
Just like give me some support. We get a few cheats going. Little kind of
Now, Coach, do you have anything to say to him?
I don't think there's an X on the top. I think it should be on the bottom.
Tell him. I mean, he's gonna give him
Don't
problems.
want to be X -1.
No, when you subtract the exponents, it would be on the top, so it would be, you're gonna take 4 minus 5, so it'd be x to the negative first up here. Yeah, so then that's gonna come down. Now you gotta put it on the bottom. You make some mistakes.
Yeah, that's
Your
just.
Z thing was, yeah, and read, I want you to look, you got 3 of them on the top, you have 8 of them on the bottom. Forget the rules, doesn't it just make sense that when you start canceling, it's gonna be leftovers on the bottom?
Yeah.
Doesn't that make sense? So just the same thing here, got 4 on top, 5 on the bottom, so the extra one.
Okay.
Don't get all hung up with the rules. I mean, rules are good, but. All right, anybody have a question about that? That's what I ended up with. You okay? All right, now we're gonna talk about interval notation. Did you use that last year?
Yes.
You did? So tell me about interval notation. What is interval notation? If we have a number line, let's say, and we put open dots on that number line and shade in between, that's called an open interval. And when we were little kids, we wrote it this way. But now that we're almost calculus students, we're gonna write it this way. That is the open interval notation, those parentheses. And I get it, it gets kind of confusing with ordered pairs, but it just depends on what context you're in. So that's an open interval. What happens if I close those dots in? Well, in my old notation, my set notation, I would do that, right? But what happens as an interval? I use the brackets, right? This is a closed interval. Now, you can mix and match, so you can have 1/2 of it open and 1/2 of it closed. That's fine. But this is called an open interval, and this is called a closed interval. And that's our notation. So in number 9, when we're sketching this, it's very simple. You're gonna put a dot at -5 and a dot, or -4 and a dot at 5. What does this tell me right here, this bracket at -4? What does that tell me? What is that dot in and color in between? That's it. Now, what about this? What's going on here? Here's my number line. Here's 6. What does that mean? Well, it's a half line, right? I'm gonna go this way. Yep, I'm gonna shade it this way. When you use interval notation, the infinity will always be open. You can't really put a dot at infinity and color it in, So you'll always use parentheses with your infinities. This is exactly the same thing, only we're gonna go that way, because this is where positive infinity is, so we're gonna go that way. Does that make sense to everybody? So now we are gonna write those as inequalities. So as an inequality, what would this one right here look like as an inequality? And this is an inequality right here. So we'd have -4 less than or equal to x less than 5. What would this one look like as an inequality?
X is less than 6.
Perfect. X is less than 6. And what would this last one look like? X is greater than or equal to 7. All right, try number 11 on your own. I'm gonna have a volunteer come up, put him up here for us. Be brave like Braden. Mr. Hasbrook, you got him?
Almost.
Okay. Come on out and put them on the board, please. When you get them done, you can bring a partner if you like. You can look there next to the problem. Now, there's just one, I don't know where I got that negative, okay. There's one thing about this, is there's one little thing that maybe we should add to that. Yeah,
On the infinity, there should be a negative.
yeah, when you're sheeting this end of the number line, this is negative infinity, remember? This is positive infinity. Yep,
Should that be a bracket?
Yeah.
that should be a parentheses. Unless I wrote it wrong. Yeah, that's an open circle. So that should be a parentheses, good work. Good, anything else? Okay, now we're moving on, we're gonna talk about scientific notation. Can somebody tell me what scientific notation is? What does it look like? I don't need a formal definition, just tell me about it. Awesome.
You use it for when you're like trying to write out numbers that are either really big or really small by giving the like significant digits that actually have like values more
Okay.
than 0, and then you have times 10 to whatever power. So if it's super small, it'll be negative. If it's really big, then it'll be positive.
Perfect. Now, there is a little rule about scientific notation that we have to remember. So what you're telling me is, I could take a number like 312, and I know that's not a super big number, but I could take 312, and I could write it 312, or I could write it as maybe 31.2 times 10 to the first. No. Why not?
That's in the single digit.
Pardon this interruption. If we could please have all students who are helping with the math and liturgy, please come down to the football field. Thank you.
Is that any of you? Okay. What's wrong with this?
These have the single digit for decimal.
When you write scientific notation, this part right here has to be between 1 and 10, right? So whatever number you put here, it has to be 1 or bigger and less than 10. Everybody knows that? Okay. So now we're going to do a couple of problems, and we want to write our answer in scientific notation. Remember that when you multiply, multiplication is commutative and associative. So this entire thing is multiplied. There's a multiply, a multiply, a multiply. So things can be done in any order. So what if we took the 1.6 times the 9? We're allowed to do that. All right. I see some calculators out going, what's 1.6 times 9?
14.4.
What is it?
14.4.
14.4. And then, since this is a 10 to the 7th and that's a 10 to the 13th, we can just add the exponents because it's like x to the 7th and x to the 10th. So that's going to be 10 to the 20th power. And that's beautiful, except that. So that's got to be a 1.44. Now again, use your common sense. These two numbers have to be the same. If you made the first half smaller, you went from 14 down to 1, so you made that smaller, what are you going to have to do to your exponent to keep it balanced out? Make it bigger. Yeah. Yeah. So there is your final answer. Now we can do exactly the same thing with division. You can go ahead and divide these two numbers. Well, 1.7 divided by 3.4, I think is 0.5. And then we're going to subtract these exponents, that's a division. So negative 5 minus 6 would be negative 11. And again, that's all hunky-dory except that number isn't between 1 and 10. So we'll make it a 5. We made this bigger. So we'll have to make this smaller. Negative 12 is smaller than negative 11. All right, try C on your own. Let's see what you can do with C. You can certainly use a calculator to help you with the multiplication and division if you want.
You okay today? Did I get the right answer?
Just make sure everybody can get that before we move on. We're almost done with this section. Who's got a question? Anybody got a question? I got 30.4 when I did all this. And then I added 12 and 4 and subtracted -3 and I gave me 19. But this number was too big, so I shrunk it down and increased my exponent. Okay? All right. Tell me about however many years there are there, 19. What's that gonna be? 1.9 times 10 to the -4. Everybody okay counting those decimal places? 3.61 times 10 to the 7. All you gotta do is count, right? Now what would this one be? 5.94 times 10 cubed. 5,940. And then times 10 to the -3rd, 0.00594. Make sure I moved things the right number of spots. Does that look okay? Alright. Okay, well we just finished P1, so that homework will be due on Wednesday. Let's go ahead and get started on P2. What is this setup called here? This picture that I drew where I got these intersecting lines. Hi Max, you guys done already?
Yep.
Good deal. You got some seats right up front here, Max. They'll look perfect for you. We're starting on section P2. What's this setup called here? Anybody know? This is called the Cartesian coordinate plane. Anybody know who it's named for? Descartes. Rene Descartes. That's exactly right. Great philosopher and mathematician. He is credited with the study of analytical geometry, which is when we kind of wed algebra and geometry together and start drawing pictures of equations. Okay, here we go. Cartesian coordinate plane, great. What is this called right here? What is this line right here called? That's called your y-axis. And this one then is called the x-axis, perfect. What is this point right here in the middle called?
Origin.
That's called the origin. Oh, by the way, the Cartesian coordinate plane identifies points in terms of an x and a y, right? When we get to chapter 6, we're going to identify points. Come on in. We're going to identify points in terms of other things, so we'll have a little bit different setup. Meredith, why don't you sit up here? Sit right here, next to Franz. Perfect. All right, that's called the origin. These 4 sections are called quadrants. Does everybody know how they're numbered? Yep, 1, 2, 3, 4, and this is the way they're numbered, right? This is 1, 2, 3, 4. Easy. Draw a scatter plot. Okay, now we're going to plot those points. I know what you're thinking. I promise it's going to get a little bit more challenging than this, but we got to make sure everybody's on target. 3, -2. 3, -2 would be right here. And 1, -1 would be right here. 0, 3 would be right here. And -2, 2 would be right here. You okay with that? Yeah, easy. All right. Now, tell me what you know about absolute value. We're going to define it formally, but tell me what you know already about absolute value.
Just how far a number is from zero.
Okay, so on the number line, it's how far it is from zero, which means it will always be positive, right? So the absolute value of x equals x if x is greater than or equal to 0. Would you agree with that? So the absolute value of 5 is 5, and the absolute value of 12.8 is 12.8, and so on. What's the absolute value, though, if x is less than 0?
Be, I guess, negative x?
The opposite of x. That's exactly right. That's exactly right. Because if you take the absolute value of negative 3, it's the opposite of negative 3, which is positive 3. So this is the definition of absolute value. And some of you are thinking, well, who cares? You will care when you have big, complicated equations involving absolute value, because you won't be able to solve them without your definition. All right. That's the definition of absolute value. So if you are asked to define absolute value, that's how you're going to define it. Now, underneath there, I wrote some kind of basic rules. Sir, why don't you sit right here? I wrote some kind of basic rules. Take a look at those and make sure they make sense while I do my seating chart here with my new people. Can you go by narrative? Yes. All right, does all that make sense to you? So we can split up an absolute value. If you got two things multiplied together, we can split those apart, or divided, we can split them apart. Now, I'm going to ask you to think about something that you may or may not have ever thought about before. So we have 2 points on the number line. If I said to you, how far apart are they? So think about numbers. If the letters confuse you, if I said 2 and 7, how far apart are they? What would you say? 5. And how did you get 5? You subtracted them, right? So the distance between these 2 points could be b minus a. It could also be the absolute value of a minus b. Would you agree with that? Think about your 2 and 7. If you did 2 minus 7, as long as you took the absolute value, you'd be okay? So the absolute value of a difference, subtraction is a difference, the absolute value of a difference is just another way of talking about distance on the number line. So, what I have there, I want you to say these 2 things are equal to each other. Now, solve using the distance idea. All right, so here we go. I know you know how to solve that equation. You've done it a million times. Probably when you did it before, you split it up into 2 equations, and you said x minus 4 equals 5, and x minus 4 equals negative 5. Well, I want you to think of it from a calculus standpoint now. So I want you to look at the number line. I want you to imagine 2 numbers on the number line. One of them's x. Or one of them's 4. That's really the only number I know is 4. But I want there to be an x out there someplace. Did someone just say something?
Mm-hmm.
What did they say?
I have no clue.
Okay.
It was just a repeat saying like people are hoping for math.
The distance between some number and 4 is 5. So that number x could be out here or out here. Would you agree with me? If the distance between x and 4 has to be 5 units. That's exactly what this says. The distance between some number and 4 is 5. Well, what could that number be then? If its distance from 4 is 5, what could that number be? 9 or -1. So the answers to that equation are -1 and 9. Simply from a distance standpoint. Let's try the next one. Oh, wait a minute, a couple things are different here. First of all, that's a plus. And absolute value is a difference. So wait a second. Can anybody figure this out? What am I gonna do? Here's my number line. What number am I gonna put here? Before I put a 4. What am I gonna put here now?
That's 6.
No, don't put a 6. This says the distance between some number and -2. Remember, absolute value, distance on the number line is a difference. Don't you subtract these two? So you have to subtract something. Well, the only way you can get a positive in there is if you have subtracted a negative number. So here's my -2. Now some other number is 6 units away from that. So if I'm 6 units away, where am I? If that distance is 6, it's actually greater than 6, but I'm going to start with 6. If that distance is 6, where would I be out here? At 4 or at -8. Now, if this were an equal sign, these would be the answers, just like they were over here. But this time, it's a greater than, which means we want the distance to be more than 6. So where are these numbers? If they have to be more than 6 away, where would they be? Exactly, Mr. Bernard, it'd be out here and out here. So my answers will be x is less than -8 or x is greater than 4. Let's write that in interval notation. Here we go. What's that going to look like in interval notation? -infinity, -8. 4, positive infinity. We're going to put a union symbol in between them because or means both. Take them both. So we use a union symbol for them. So -infinity to -8 or 4 to infinity. When you study limits in calculus, you're going to need to understand that concept. So we're going to practice it a little bit more. Write as an absolute value the distance between x and 6 is 7. So the distance between some number and 6 is 7. So that number can be 7 units this way or 7 units this way. What will that look like in terms of an absolute value? The distance between some number and 6 is 7. The distance between -3 and x is less than 5. the distance between negative 3 and x. X plus 3, very good, sir. Ooh, now we got some letters going on here. The distance between x and a is at least d. Greater than or equal to d. Perfect, perfect, perfect. Okay, we're doing great. Now we're going to talk about midpoint. If you're on the number line, how do you find midpoint? So we've got, here's my number line. I've got a C and a D. How do I find the midpoint? This guy right here, how do I find him?
You average them, so it would be C plus D divided by 2.
Yep, and I totally love that word because that's going to be so helpful when we graph our trigonometric functions. Midpoint is average. It's just the average. You want to find the middle value. You want to find the average. So to average, we're just going to add and divide by 2. Perfect. We don't need any fancy formulas, even though there is a midpoint formula. We don't need it. Midpoint is average. So, so good. So what is the average of 6 and negative 9? What would that midpoint be? 6 and negative 9. Negative 3 halves. Now I saw the calculators come out on that one. Probably shouldn't need it. 6 minus 9 is negative 3 divided by 2, so negative 3 halves. Let's see if we can do this one without a calculator. What's the midpoint of negative 2/3 and 7? Well, we're going to add them, right? So that's be negative 2/3 and 21/3. So that'd be 19/3. Wait, that's not the midpoint. We have to add them and then divide by 2. Since they're fractions, how about if we multiply by a half? Would that be okay?
Yeah.
So your middle point of negative 2/3 and 7 would be 19/6. Anybody have an issue with that? All right, let's jump up to the coordinate plane then, the Cartesian coordinate plane that we were talking about a minute ago. Anybody know the distance formula?
It's the opposite of b plus or minus.
That's the quadratic formula,
shoot.
which is we're going to use here shortly. Don't worry, we're going to use that one in the next couple days. But right now we want the distance formula. So I'm out here in the coordinate plane. I got a point and a point. How do I find the distance between them? Hasbro?
D to the second minus D to the, or x to the second minus x to the first, squared plus the y squared minus y to the first.
Perfect. Remember, these are called subscripts. So if you're going to say them out loud, you'll say x sub 2, not x to the second. That means something different, right? So x sub 2 minus x sub 1 squared, y2 minus y1 squared. Perfect. And what does all this stand for? What do these things stand for here? You have 2 points you're finding the distance between, and one of them is x1, y1, and one is x2, y2. All right, what about midpoint in the coordinate plane? Again, we got a formula, but we don't really need it. How do we find midpoint? We average. So it's x1 plus x2 and y1 plus y2. Midpoint is an average. Please don't forget that. So with midpoint we add, it's an average. Distance is a difference. You subtract to find how far apart something is. So those are subtractions. Good. Let's see if we can find the distance and midpoint here. Do I have a volunteer to come up and do the distance? And then another volunteer maybe to come up and do the midpoint for that? I know you've done this a million times. So do we have a volunteer? now, or you want to do midpoint? Alright, what do you guys think? Did these guys do a good job? Root 10 is this answer, and 1/2 7/2 is that one. Everybody okay with that? Alright. Let's go ahead and do C, or B. It's no different, it's just got decimals. Go ahead and do that on your own. Let's compare answers real quick, and then we'll move on to the next problem. How do these look? Do these look okay? I want to talk a little bit about this one because it's really not considered very good form to leave a decimal under a radical, because that literally means the square root of 25 tenths. Would you agree with that? And what do we know about radicals and denominators? We're not supposed to have them. So it probably, even though this is what you get, because the problem's all done in decimals, it probably isn't a good idea to leave it that way. So I think I'll change it into a fraction and simplify it. So that does reduce to just 5/2. And then I'll multiply the top and the bottom so that I have the square root of 10 over 2. Did I pull a fast one on you, or does that make sense to you? Remember, this is the square root of 5 over the square root of 2, so we got we call it rationalizing the denominator. So now the denominator is not a radical anymore. Okay? All right, let's do, you guys have been really good. Let's do one more problem. We'll figure out how we're gonna do math. All right, find A if M is the midpoint of AB. So I'm gonna go ahead and just draw a picture of this. I am very visual. find point A. M is negative 3.6. And B is 2.4. Okay. So we know the midpoint, and we know one endpoint, and we have to find the other endpoint. All right, so take a minute and work on that with your partner. Or by yourself, I don't care. Work on it, and see if you can come up with an answer, and then I want you to tell me how you got the answer. Philip, you got an answer already? What do you have?
Negative 8.
Okay, there's one suggested answer. Anybody have a different one? Still working on it? You think he's right, Bronson? Is that what you thought, sir? Okay, Philip, how did you do that?
So I set it up so it's x plus 2 over 2 equals negative 3. And I did the same thing with the y side.
So Philip actually used that little midpoint idea we had up on the board. He said, I don't know what x is, but I know that if I average it with 2, I should get negative 3. And then he just solved that equation. He did the same thing with the y's. Perfect. Anybody have a little different idea, Bronson?
What I did was just find like the transformation to get to the other point. Like for the y's, to get to 4, you had to subtract 2. So the other way around would be to add 2 to get you your y value. And then you had to add 5 to get to 2, and then you can subtract 5 to get to
Exactly. So another way of thinking about that is if we go this way on our line, if we start here and go this way, from 2 to negative 3 is back 5. So obviously we have to go back 5 more if this is the midpoint. And then from 4 to 6 is up 2. So we gotta go up 2 more to get to that point. The very, very common sense approach. Super. All right, let's stop there and talk about church. We're gonna head out to the football field. And you're going to sit on the ground.